probability mass function, it's very critical to describe all the discrete probability distributions, guys, right? So whenever you see discrete probability distribution, this is the function which should come to your mind, right? So let's see, using a simple example, what is probability mass function and how it helps us to describe the discrete probability distribution, right? We'll take the same example we saw in our last video where we were actually learning about the probability distribution. So here the example is, it's actually a real world data. I found it in survey and I just copied it over here, guys. So what we have here, we have different households, 101401, almost 1 lakh households data we have collected, and our random variable says how many TVs are there in these households, right? So now 1218 households have no TV, 32,279 have only one TV, 37,961 they have two TVs, right? And like that. So this is how our data looks like. Now this is the same data set we used in our last video as well. So after that, what we were doing in our last video, we were calculating the probability corresponding to every value of my random variable, and that is what we call it as probability distribution, right? So what was probability distribution? The table in which we assign probability to every value of our random variable. So that is our probability distribution. That's what we learned in our video, right? Now we have our, when we are calculating the probability corresponding to every value of your random variable, that probability is basically, we call it as probability mass function, guys, right? So we have probability mass function. You already know about this. This is something we have already learned in our last video, guys, but we didn't know the name of that, right? I did not tell you that. So now probability mass function is nothing but, we represent it using a small f, and it's nothing but probability of your random variable taking a particular value x, right? So capital X we use to explain the random variable, or it's a notation for random variable. And now if the values it takes, we represent them using small x. So this is the notation every book you will have, right? So probability of your random variable taking a particular value, small x, that we call it as probability mass function, guys, right? So whenever you are calculating, so the PMF over here, so when you have number of TVs 0, so the probability will be, or your probability mass function value will be 101401, right? That is 1218 by total number of households. Now when the number of TVs are 1, then 101401, so 32,279 divided by 101401, right? So that value. So now when you have values, probabilities for all the values in your random variable, so ultimately what you are calculating the probability mass function, right? So just remember this notation, guys. Small f of x is equal to probability of x is equal to small x, right? Now when you have this, generally we can create a bar plot, right? Or you can say the kind of bar chart or kind of histogram, guys, that also you can say, that it tells you about the frequency of your data, right? So now at value 1 we have almost around 0.01, right? That number or that frequency, there those many households are lying when you have number of TVs 1, right? Similarly for value 2 you have almost 30%, right? So that is 0.3. Similarly for at value 3 we have 0.37, that is 37% of the observations are having the number of TVs 3, and like that, right? If you take the sum of all these probabilities you have calculated, or probability mass functions, the values you have calculated, that is total come as 1. This is the property, guys, because all the values your random variable can take, if you calculate the probability of them and you sum all of them, you will find the probability as 1. total of those values, the values of probabilities will be 1, right? So now let's look at the official definition. We have looked at the example. Now the probability mass function characterizes the distribution of a discrete random variable. Let x be a discrete random variable of a function. Then the probability mass function of a random variable x is written as or given as this. Px of x, which is nothing but you can specify in the books. You will find small f of x is equal to probability of x, your random variable taking a particular value, right? For all x belongs to the range of x, right? So now this is your probability mass function. Now there are few conditions. We have already discussed them, guys. So now as this is the probability, so your PMF is nothing but a probability. So this snapshot I have taken from one of the very popular book for applied statistics, guys. That is Applied Statistics for Engineers, right? This is very popular book. I use this book in my masters. You can also follow this book, guys. It's very good and very user friendly for beginners, right? So now this is by Montgomery. You can actually Montgomery. You can find the PDF of this book over internet, guys. Just search this, Google search Applied Statistics for Engineers Montgomery, and you will find the PDF. You can learn all these concepts which I am teaching here. So from this particular book, right? So now for a discrete random variable x with given possible values, a probability mass function is such that, as this is a probability, guys, probability mass function. So now that probability we know, the value will always lie between 0 to 1, right? Or you can say f of x, right? So f of x will be between 0 to 1 and it will always be greater than 0. So the first condition is correct. Then for all the values in your random variable, when you make the sum of all those probabilities, then you will find the sum will be 1, right? So summation of I is equal to 1 to n number of observations in our random variable, f of xi, right? Then that should be 1. The third is it should be probability of x is equal to xi, right? So this, I think I am assuming that now you understood the concept of probability mass function, guys. Now for discrete random variable, this probability mass function is very useful. How? Let me tell you that. Another snippet from the same book and very helpful, guys. So how do we calculate? Let's say we have this particular variable, right? So we have this number of TV variable. If I ask you a simple question, what is the expected value of this random variable? Expected value, or you can say average, guys, right? So what is the expected value or variance for this particular random variable, number of TVs? Can you give me that calculation? If you can do it, please do it so that you can verify your answer, right? Otherwise, we have simple calculations which we can use probability mass function, right? So now the calculation is very simple, guys. So we have our random variable, we have probability mass function, and let's say 1, 2, 3, and is corresponding to this we have some values x, y, z. These are nothing but probabilities, right? So now to calculate the average expected value will be equal to summation of all the values, and where you have the product of this random variable, we can write it as small x, because the value of your random variable into your probability mass function, right? So you can see this is the one, summation of x, f of x. So this is the simple calculation for average or expected value of your discrete random variable. Any random variable you have, any data you have, the expected value, how can you calculate? This is the way you can calculate, guys. A lot of people does not know about this. So that's why in interview, you will find such kind of questions. Let's say you have some data, and this kind of case studies you will find in the CAT exam as well. right? So there also this kind of information is very useful. Now when it comes to variance, we have the simple formula for this, right? So expected value of x minus mu square. So if you can do the calculation, you will find the formula this, right? So square of your random variable values into probability mass function, sum this for all the values in your random variable minus mu of square, expected value square, right? For standard deviation, you just need to take the square root of variance, right? So these are the different formulas we have. Now let's apply these formulas to calculate the expected value and variance of our data, right? So now this is our data where we have PMF, right? Now if we need to find expected value, as I mentioned, you need to take the product of your random variable values and PMF. So how will you calculate this? The formula is very simple. So now, yeah. So 0, that is number of TVs your random variable value, into corresponding to this value your PMF, that is 0.012, plus 1 random variable value into PMF corresponding to that value, right? 0.319, and keep on summing all these values, right? So then you will get your expected value, which is coming as 2.084. So that's your expected value of number of TVs. On an average, you have 2.084 TVs in an household, right? This is how you calculate the expected value. And then variance. Again, use the same formula we have. That is x minus mu square into f of x, and sum this for all the value you have in your random variable, right? So x, for the first value, it's x, that is 0, minus our expected value 2.084 square into its PMF 0.012. Similarly, you will keep on calculating this, and finally sum the values of all this. You will find the variance, which is coming as 1.107, right? Standard deviation will be square root of 1.107. So now that you can calculate using calculator, and you will find your standard deviation. So now if you find any data in real world, you will be able to calculate the expected value, variance, and standard deviation of that particular data set, guys, right? So now that is your probability mass function. Very important, guys. This concept we use in the industry very frequently, right? And yes, so now we can say the average number of TVs in a large number of randomly selected households will approach the expected value of 2.084, right? So this was from the sample. But now if we want to infer about the population, we can say that in a large number of roughly randomly selected households, the expected number of TVs or average number of TVs in that household will be 2.084, approximate to that, right? So this is how we use probability mass function. I hope this is clear, guys, right? Now let's talk about the second function we have, that is cumulative density function, right? So this function, we can use it for discrete probability distribution as well as continuous probability distribution, right? So now let's understand what is cumulative density function. Now, if you remember, guys, in our last function PMF, we were talking about probability of my random variable taking a particular value, right? Probability of x is equal to small x, right? This is our PMF. Now, in case of cumulative density function, from the name itself, it's clear, guys, it's cumulative. And cumulative means less than a particular value, you have to sum all those, right? So cumulative probability density function refers to the probability that the value of a random variable falls within a specified range, and that range is basically falls less than a particular value, right? So now this one will write in this particular form, guys. This is our CDF, cumulative density function, is represented using this formula, guys. Probability of X taking value less than any particular value in your random variable. And remember, there is an equal to sign as well. Okay, now let's understand this using the same example. Very simple, guys. So we have number of TVs 0, 1, 2 till 5, and then we have number of households. We have calculated the PMF. Now you know that how we calculate. What is the formula for CDF? Probability of X less than equal to small x. Now what we do, for the first value in your random variable, that is 0, the probability is 0.012. So now if I ask probability of X less than equal to 0, what will that be? Or what that CDF value will be? It's the same because there is no value less than 0, right? So it will be 0.012, right? Now for the second case, we will ask as X less than equal to 1. So now for that particular case, we need to have the probability in this form plus, right, probability of X is equal to 1, because less than equal to 1, your random variable takes two values, 0 and 1. Now for both you have to sum the probability. Probability of X is equal to 0 plus probability of X is equal to 1. Now in that particular case, it will be 3, 3, 0, right? Similarly, now if I ask for the next case, X less than equal to 2, and for this particular case, you have to sum 3 probabilities. Why? Because there are 3 values your random variable can take, right? So that will be your CDF. Now you sum all of these 3, you will get. So now you need to do the sum of this value and this value. You will get your result, right? Now you just do it for all the values and you will get your CDF, cumulative density function corresponding to any particular value, right? So now that will be calculated, as you can see. As you know, for the last values or for the last value in your random variable, it will be 1, because you know sum of all the probabilities will be equal to 1. That's the condition, or that's the characteristic of your probability mass function. If you sum all the probabilities corresponding to the values of your random variable, you will get the value 1, right? I hope this is clear. Okay, so that is your cumulative density function, guys. Now we have a quiz, and that question is for you. This is very, again, interesting problem, guys. Let's say how many messages, that's your random variable, how many messages you will get in your mobile in next 1 minute, or let's say in 1 hour, right? And based on the data, these are the possible values for your random variable: 10, 11, 12, 13, 14, 15, right? 10 to 15 messages on your WhatsApp or anywhere, you can say, right? Now probability is already given for that. Based on the past data, we have the probability that the number of messages will be 10 in the next 1 hour will be 0.08. Similarly, for 11, it's 0.15. This is nothing but what? All these values, these are PMFs, right? Probability of X is equal to small x. So this is nothing but your PMF, probability mass function. What you need to do? You have to calculate the expected value and the variance, guys. Calculate, find the right answer and write it in the comment section, and I will check it out, guys, and definitely I'll reply on that. Okay, you know the concept. How do we calculate expected value and how do we calculate variance or standard deviation? You will be able to answer this, and this is very important, guys. It will revise all your concept which you have learned so far.